very first robotics team.
Oh, okay.
Kind of like and between intermediate and beginner, I'd say, or just intermediate.
So is this your first year or second year?
This is our first year.
You're saying first year, but you're saying intermediate.
Yes,
No,
because
no,
some of us took a
like
class
beginner.
and we just did a little bit of like doing like we used the Mindstorms last year.
Oh.
So
Okay.
yeah.
And then this year you're coming in with
Yeah.
with
Yes,
coming to
brand
the
new.
tournament, huh?
Yeah.
Awesome.
Now,
So what's your robot's name?
Cortana. So we used configuration management, and basically we made different versions of it. Like if we, for example, if we made the first version, we would call it version 1, and then the next day, if we made modifications to it, we would save it as is and call it version 2, and so on and so forth. And so if we messed up on one of the versions, we can always go back to an older version and edit that.
Very nice. So that's on the software, on the programming? Did you do that with the hardware too?
oh yes, in a way, yes. Because
In a way.
as the operators tested it out, we saw the need for modifications to the robot in and of itself. For example, for us delivering the shark, which we're about to demonstrate to you right now, we found the need for the fork arm, for the side arms, which allow us to deliver the the shark to the second square. And also, we also developed this arm to help us deliver the policeman with trainer to his square. And also, these blocks on the side definitely did help us when pushing in the cow sow, collecting the bee and the pig over there, and the zoologist.
And we put the motion sensor, so that way it would be easier and we wouldn't knock the robot out of place while we were pushing the buttons to actually turn the robot on. So we would basically just turn the program on, fix the robot, and then put our hands where the motion sensor is, and then the robot will keep on going.
Yeah, and so when the operators push the buttons, it doesn't get thrown off by the buttons.
So you're using the motion sensor as a controller? Okay.
Oh, I know why.
You're responsible.
It can be a little off.
How many missions did you do?
We did the shark, we did the pig, we delivered the pig, we did the milking automation, we dropped off the zoologist and the policeman.
Oh, and also, we
And the
also
dog.
do the dog, yes.
Okay. And how did you pick those missions?
Basically, we made a list of tasks. Made a list of all the tasks, and then we picked out the ones that that gave us the more points, but it was worth the time, and it wasn't like as impossible to do.
Yeah, for example, the milk for the feeding, we would have had to get all food pieces, take it back to base, and then deliver them individually to almost all the different ones. Sure, we could have done 2 and gotten the points for that, but yet again, it wouldn't be worth all the extra effort. Whereas if we could just do something like the shark, the dog, milking automation, or perhaps delivering the zoologist, it would be, I'd say, a little bit more easier and be more saving time.
You guys break up the tasks. You have
yes.
Designers, builders, right?
Yes.
Yes.
Engineers.
Engineers, mechanical engineers, and software engineers.
Okay.
And who's the operators?
We're the operators,
Okay.
and those two here are the mechanical engineers, those two there, and here are the software engineers.
Oh, very good.
So we divide into 3 groups so that everyone would have a task to do equally.
Now, with the software engineers, did you work together to work through each step, or did you kind of assign specific?
Well, we did work together on some of them that we thought was a little easier. We kind of worked individually. For example, the shark, we just did like a few goes and then we did it individually. But for the cows, for the milking automation, we worked together and we, one of us programmed the robot to go all the way over there. one of us programmed the robot to go around, and then the other one programmed the robot to deliver the zoologist to the square.
So you have a sequence of multiple
Yes.
missions here?
So,
Is that hard to do?
Not really. We actually did make a plan of action during every single meeting, and actually we had different phases of it. For example, we have the phase of delivering the pig to there, backing up, and then pushing in the cow, and then moving to get the milk out, and then collecting the zoologists. And then those would all be different phases. That way we could divide up the work.
At first we made it a little faster, but then we
Yeah.
realized that going slower would give us a little more accuracy, and so we messed up a little less once we got slower.
Okay, but you have a sequence of how many missions? on that one?
I'd say about 4, one for dropping off the pig, one for pushing in the cow, the other for driving the cows out, and lastly for collecting the zoologist.
So 4 tasks
No,
in
Are you using sensors to realign your robot?
We were actually going to do that in the beginning, however, something happened with the Bluetooth, so instead we actually decided to build this guide here.
Mhm. So basically you've got a jig
An alignment jig, yeah.
to help you align it.
Yes,
To
instead
start
of using
with.
the gyro.
Okay. Very good. Well, what's your success rate in your complicated one?
I'd say we would be pretty successful. It didn't take us that long to achieve the tasks, right?
Well, on some tasks that are easier, for example, the shark and the dog, it did only take us a few tries. However, to perfect the milking automation, it did take us
multiple
tests.
Okay.
Any other questions?
Compared to some of the other, I mean, you've had a chance to see other robots, is there anything about yours that you think is unique or?
the top right here. Because we put the dog and the trainer on top, like right here,
Mhm.
so that we can drop it on that square over there. So we make it move all the way down there, and it turns, and then it drops it. And we also have the side arm so that we can push some of the stuff so that we can put it in place. For
We all
example, like the pig and then the bee and then.
Can you show me your attachments again? Do these move?
Yeah.
Okay, and you don't have to actually take them off, you can just
Yeah.
tilt them up.
We also decided, at first we thought we could build like a lot of stuff like 5 different arms or something. But then we soon realized that there would be a lot of wires, and then the wires would get stuck on the tires, and then there would be a little more weight, and it's too much. And so we realized to make it simple, but have it do a lot of tasks.
Yes, because if we did put too many sections on top, we realized that there was so much of a more open space for a failure. For example, if we attach, say, I don't know, 2 more attachments,
Yeah.
that means it'd be how many locations for failure? There'd be the tires, the motors, motion sensor, and plus the 2 other ones. That means there's a lot of open spots there. Whereas we decided to leave the minimum amount of attachments for the reasons Haven said and for weight reasons.
Very good.
We
And
heard
you
the
guys
term.
said this is your first year?
Yes.
Have you heard the term KISS? K-I-S-S?
Keep it simple, stupid.
See? Anyway, sounds like you're using that concept.
Well, thank you very much. You guys have a great robot, and wish you all the success this afternoon in the competition.
Good luck.
Yes.
Thank
Thank
you
you.
so much.
Thank you.
Make sure you